Okay, first let's see WSS, the wide sense stationary process. First, if the mean value of the process is not related to t and the outer correlation ext1, xt2 is only related to the difference of t1 and t2 here, we let tau equal to t1 minus t2. So we can say that this process is a wide sense stationary process. And here, first, let's see the strict sense stationary process. The nth order statics of xt is independent of time suite for any n. This is the strict sense stationary process SSS. Here, an important property is that we can use SSS to imply WSS, but WSS cannot imply SSS. Okay. The second, independent increment process xt, if all its values xt for t is equal to t0 and for t less than 0 and t more than t0 plus a are mutually independent, we can say that say t1 t2 is equal to 0 if the difference between these two times are more than a. Here a is a parameter, so we can say that this process is a correlation independent increment process. Okay, Markov process for a chain of times t1 more than t2 more than t3 more than tn. If this equation is right, also we can say that the outcome at any instant to depend only on the outcome that precedes it and none before that. In other words, we can say that the past does not imply the future, and this is called the Markov process. For a Markov process, the second order PCDF, it is enough to characterize the Hoover statics, because we can prove that we can use the second order PDF because the nth order statics of xt is independent of time suite for any n. So we can say that we can use a second order enough to characterize the Hoover statics. White noise. If white noise, the definition is that if all the values of a process, here we can see that NT, NTI and NTJ, they are uncorrelated for every TI and TJ. Of course, TI is not equal to TJ. Also, we can say that CDI and TJ is equal to 0. And this process we call the white noise process. And for a white noise process, if NTI and NTJ, they are also independent. So we can say that this process is a strict white noise process. And here we can say that say T1, T2, it is equal to Qt. Qt is arbitrary function and given arbitrary function and times sigma tau. Here sigma tau is an impulse function at t1 is equal to t2.